Hey there, this is Mrs. J, and we're going to take a quick look at the second assignment on electricity. So we're still in the beginning, very simple stages. We haven't done a full lesson on anything yet, so don't be afraid of it. It's actually really cool. Okay, so you were working on that Tinkercad circuits. Let's try a more simplified one. So we have an assignment here. It says to create a series circuit using a 9-volt battery, a 470 ohm resistor, and 2 LEDs with some wires using Tinkercad. And we're just going to run the simulation, see if it works. Once it works, we'll take a screenshot and we'll upload it. So very simple assignment. You should be able to do it after completing assignment number 1, but I thought I'd take a minute and walk through it with you. There's also some more information down here, and it's just FYI. We'll go over it together later, but if you're finding you have an interest in this, feel free to browse through this PDF and then this 12-minute tutorial from YouTube. It's actually pretty interesting. Okay. So let's see. Let's go to Tinkercad and let's go log in. So you want to make sure that you're logging in such a way that you're in one of my classes, which you should have already figured out sometime last week when we joined up the code. If you need the code, go back through Google Classroom, make sure you're in there. All right. So when you come over on the left side here, you have 3D designs, you have circuits, you have code blocks, you have lessons. Go to circuits. And then we're just going to make a nice new one for today. So you might have a couple things going here. Make a nice new one. Create a new circuit. It gives you a name up here. It defaults to something really wonky. Feel free to change it. You don't have to. I wanted to make sure you're familiar over here. You can switch from basic to all to get everything you need, or you could just switch up what you're looking for. So scroll through, switch to all, scroll through, see everything they have in there. There's a lot you can do with Tinkercad. It's pretty cool, actually. Lots of components you can use. We even have a potato battery and a lemon battery. Feel free to play with those. We're going to use a small breadboard today. They have long, they have mini, they have small. We use a small one. So just click that and drag that in. This one looks like the ones we're going to use in our class, but no big difference between all of them. We're also going to need a 9-volt battery. So I'm just going to put that in there. 9-volt. You can also slide through and get it. Oh, look, cheater ones. Drag that in there. There you go. Let me pause for just a second. Okay, I wanted to grab the picture. It's inside your lesson here if you scroll down a little bit. There's a picture that shows the inside of a breadboard. Let's just take a quick look at it together because we don't get to see the inside too often. So you have the top over here removed. Someone took it off, and this is what's going on the inside. We're in the classroom. We're going to add wires. We're going to add light emitting diodes or LEDs, and we're going to add the wires to the power supply so that we can set up a little circuit. This is what's going on underneath. So they're just metal strips going in down here. We call these raceways right here. And then these are the buses. And you see like there's a long strip that connects them together all the way up the whole length of the breadboard, this side and then down this side. So say you're over here and you're down over here in this row and it goes F, G, H, I, J. Right here, there's 5 of them. See if I get in there a little closer. Nope, can't. There's 5 little holes in here. Whatever you plug into this side, if you come on this side, this is what's underneath it. So when you put your wires in or your LED in, this is all connected. So those 5 go together, and it's the same for each one of those rows. You'll see that the columns, like all of column I, is not connected. There's spaces in between. But on this side, positive and negative, these are connected up and down. Just want to take a look and see what's going on inside there. It's actually pretty cool. Okay, so back to Tinkercad. Let me make sure this is giving me sound. Back to Tinkercad. We have to bring in, so let's do the wires. Let's get the wires hooked up on here. Oops, I didn't do that. I'm trying to move it. Okay, so let's get this battery hooked up into the bus, the line that goes down here, the negative and the positive. Let me scroll in a little bit. Okay, so come up to your wires. We want to use normal. We're always using normal here. And then I'm going to use black. I'm going to go from black or negative. I'm going to come across. You can put it on the end. I'm going to just put it in the middle here so we can see it a little better visibility. Then I'm going to switch, keep it on normal, switch to red. Come over here to my positive side. I'm going to come out this way. If I left click it, lets me make a nice little turn. And then I'll go into my positive unit and I'll scroll in so you can see it. Why did that stay black? Sorry, I missed that there. Okay, so black for negative, red for positive. In real life, oh, excuse me, just a second. In real life, they are the same materials in the wires. There's no difference in the wires. The color codes are used for safety. So I make sure we're starting to learn that black is negative, red is positive. Okay, and then we need to bring in a resistor. So let's come over here, type in RESISTOR. Oops. What did I do? Don't be me. Trying to come over here. Okay. Oh, look at that. It's seeing some sort of whatever I'm writing. Okay, well, it's on the top there. When I typed it, would start running it. Oh, R for run. Got it. All right, so we're just going to grab any resistor that comes up there. We want to make sure, I'm going to zoom in a little bit. We want to make sure that the resistor is somewhere on that negative row. It could be anywhere. It could be down here. It could be over here. We're just going to put it, I'm going to drop it right here. So you can do it the same for now, or you can move it along, but it has to be in the negative. So what happens is we have some negative electrons flowing out of here. We want them, remember this has a wire going across it, right? So we want them to flow and catch the resistor and be like, oh, hey, let's go hang out with you before they come out into your board on they come out on this row. I have it on 17, and they would be calmed down. The resistor is going to calm them down before they come back out here. So we say, hey, whoa, electrons, slow your little butts down before you come across here. So it's got to be in the negative there and not over here on the positive. And I think we have to change it. So you want to just select your resistor, and I will teach you eventually how to read these bands and what the gold means. You can look at one in real life and decide what size it is just by counting the colors. It's pretty cool. And I think we're going to make it 470, but not kilo ohms. We're going to go to ohms. A little bit big there. Let me just double check that that was correct for the assignment. It said 9-volt battery, 470 ohm resistor, 2 LEDs. All right. We're good there. Okay, I hope I didn't just break the video. Okay, so the next thing we want to do is bring in an LED. Right here. Okay, so LED, light emitting diode. Not a light bulb, but a light emitting diode. Doesn't have a resistor in it. This one, just a little LED. We're going to bring that in, and we're going to line it up right with the resistor. There you go. Okay, so on the left side here, see when you hover, it says cathode. Doesn't get any bigger. No. And then on the right side, when you hover, it says anode. These are some things you have to start learning. So cathode is the negative side of the LED, and it's a shorter wire. So in real life, when you take it out, you'll see it's shorter than the other one, and you'll see that in some of the PowerPoints I shared with you. And the right side is the anode. It's longer, and what we do is, see how when I hover over it, it goes away, but you see how the right side is bent? It looks kind of like it's walking. We purposely take the wire and we bend it so that we know it's the anode, because sometimes they're just a thin little wire and you're holding them in your hands when you're using the real life ones, and they get so bent just from manipulation, you can't tell which one's longer or shorter. So we always bend this one like it's a little bent knee, and that's the anode or positive. So negative, positive. And we do that by going, see, we are negative, so we have electrons flowing through here. They have negative charge. They're coming through the resistor, and they're coming down to this LED. So let's bring in one more LED, and I'm going to line up my negative or my cathode along the anode of the first one, because they can continue. So this is in the row with the resistor, and this one's in the row with the first LED. I'm going to change this color just to have some fun. There you go, red and blue. Okay, now you have to think to yourself, if I turn this on right now, will it run? Is it a closed circuit? I have negative electrons coming into here. They are reaching the resistor. They're coming into this LED. They're going through the LED. They're coming down to this cathode, going through this LED. But how do they get back to the battery? They're not. So we need to fix that. So you have to close your circuit for it to work. And to do that, we're going to go, let's see if I can do this right. We're going to be in the same row as this anode. So we're going to click a wire. And we're going to come across so that now we're in this bus that comes along right here. So now we're going to zoom out, drag it over, start your simulation, and there you go. Pretty cool, huh? Okay, I want to keep it simple to give you a little background information. Thanks for watching. You guys are awesome. Just in case you're still watching, try this. Click on your resistor. Make it really small. See what happens. Oh no, you blow up your light bulbs. Why? I lowered the resistance. My light bulbs went on fire. Why? Thanks for watching.